Okay, so in this question, we're asked about the gas going through a cycle. We're not told anything about the cycle, so let's put it this way, A, B, C, D. But it could be any shape and it can be going in any direction. And we're asked what can we say about the change in internal energy as it completes one complete cycle. Well, we know that internal energy is a function of the state. So if it goes from A and around any path back to A, then the change in internal energy is going to be zero, as the internal energy is a property of the state. Okay, next we're asked about the change in entropy. And through the same argument, entropy is a property of the state. So no matter what path we take, if we end up at A, we end up with exactly the same entropy. So the change in entropy is zero. So as entropy is a property of the state. Now, the work done and heat do depend on the path. So for example, if we take the path shown in this diagram from A to B to C to D, we can see that the work done on the gas from A to B is large and negative. B to C it's zero. C to D it's small, it's this area, and that's positive. And from D to A it's zero. So the work done for this one, the A to B, is large and negative, so that's the biggest. So the work done would be negative. But if it went around the path in the opposite direction, it would be positive. So we don't know if it's negative or positive. But what we do know is that the change in internal energy is equal to Q plus W, and that this is equal to zero. So this tells us that Q is always equal to minus W. So that's all we can really say about a general cycle.